Hi, I'm John Park. Look what we've got today. This is a giant blade from a wind generator. Now, a generator with blades this large can put out 20 kilowatts, which is enough to power a small neighborhood. Today on the Maker Workshop, we're going to build our own wind generator, one with slightly smaller blades, like this. Now, this isn't going to take you off the grid, but it will charge a 12-volt storage battery. And the best part about this project is that it demystifies the process of turning wind into electricity. The first question is, where do you get a generator? Well, you can turn a motor into a generator. Like this one, we pulled it from an old treadmill. And it's perfect for our project because it has this removable flywheel that we can attach the turbine blades to. As far as the electricity part goes, watch this. When I attach a voltmeter to the leads and spin the shaft on the generator, I get electricity, about 6 volts or so. This is perfect. All I need to do now is attach turbine blades to this flywheel, and I've got a wind generator. Commercial turbine blades are carefully engineered and cost a fortune. A maker named Abe Connolly came up with a far cheaper solution using PVC pipe, 8 inches in diameter and 24 inches in length. Now, the 8-inch diameter gives you the proper curvature to efficiently convert the straight line motion of the wind into the rotation of the turbine. And this is Schedule 80 pipe, which is a heavier duty PVC that makes a very strong blade. Now, you probably won't find this at the average hardware store. We had to talk to a plastics supplier to come up with a short length of this that was remaindered from another project. Now, the first thing I'm going to do is prepare this for cutting. I'm going to clamp it to my workbench so it doesn't roll around. And then, this is a really cool trick. I'm going to take an angle iron and set it on the pipe here to create a nice straight line. Now, I'll measure 5 1/4 inches, and I'm actually going to create 3 lines for my cuts. So here's the first 5 1/4. Mark it, and set my angle iron on here. If you press this on firmly, you're guaranteed to get a parallel line. I'm ready to cut the pipe. I'm clamping it down with some C-clamps, and now I'm going to cut it with a saber saw using a medium fine blade. Take your time. This is heavy-duty plastic, so it'll be slow going to get through it. Now, don't forget your safety glasses, and I wouldn't wear your best clothes because this is going to kick up some dust. All right, I finished cutting out my blanks, and I'm actually going to be able to get 2 blades out of each of these. You can see where I've marked it up. That's how it's going to cut. And I'm also going to remove this little notch out of here to reduce the amount of turbulence between blades. Now, you could cut this on a bandsaw using a jig. I'm actually going to use my saber saw and just clamp it to the table, do half the cut, and then flip it around and do the other half. I finished cutting out all 3 of my blades. Now I want to shape them into a wing shape. This will transfer the most wind to the generator. The way to do that is to put a rounded profile into this leading edge, that's the shorter one, and a tapered profile into the trailing edge. I'm going to use a sander to do this, but I'm going to be careful to stop about 2 inches from the end so that I can secure my bolts here. And make sure that you wear goggles and a mask for this. It's going to kick up a lot of dust. All right, after a good bit of sanding, I've got a nice wing shape on all 3 blades, including this really sharp trailing edge. Now, I need a way to attach the blades to the flywheel, so I've drilled 2 holes into the end of each blade for a 1/4 inch bolt, and I'm going to need to drill and tap the flywheels to attach them. Here's another flywheel. I've put a little pattern on here. I used a protractor to get 3 evenly spaced holes, and you can find a full set of plans on our website. Now, it's time to drill. I I need to thread these holes for a 1/4-inch bolt, so I'm going to use a 1/4-inch tap wrench. I'm going to put a little bit of cutting oil on here, and then I'll start threading it with my tap wrench. And the trick here is to go in like a half turn and then back out to let some of the metal chips fall through. Do it nice and steady so that you get a good straight threading into the metal, and once I'm all the way through the flywheel, I'm done. Okay, I've tapped all 3 holes in the flywheel, and now I've attached the blades using 1 bolt each. Now I'm going to measure the distance between the blade tips. I want these to be perfectly even so that I know where to drill the other 3 holes in the flywheel. Now this exact alignment of the blades is critical to get optimal performance of the wind generator. We need to put the generator on a frame that can point into the wind. So I've built one out of some channel aluminum, and I've attached a tail here. Now I made this tail out of sheet metal, put a pattern on it, and cut it out with some tin snips. Watch out, because you'll get some sharp corners and edges, so you can deburr that with a file. Now, the whole frame is going to sit on a pipe flange like this. That's where it's going to pivot. So I'll attach that using a bolt and washer and screw a nut on through the other side. We'll attach the wind generator to a piece of 1.5-inch pipe. You can get this at a steel yard. Here I've attached it to a floor stand so that I can set it up. So that the frame can spin freely in the wind, I'm going to attach it to a pipe union. The way this works is I'll set these 2 together and screw this on, but leave it just a little bit loose so that this spins freely. Now I'm ready to screw the frame on. I'm just attaching this pipe flange to the pipe nipple, and now this will turn freely. So now it's time to attach the generator. I've attached the motor to the frame with a couple of hose clamps. Just going to tighten this one down, and now I'm going to get my finished blade assembly. I'm going to attach this to the shaft of the motor. Now, to make this a little easier to work with, I cut a notch with a hacksaw into the end of the shaft. So this way I can take a screwdriver, fit it onto there, and since this freewheel is threaded, it's just a matter of turning this to attach the 2. And once I get that on there, it should turn freely. Check it out. Beautiful. The voltage produced by a wind generator is pretty uneven, just like the wind. You don't want to plug a device directly into this. Instead, you want to use it to charge some batteries. In this case, we're using 6-volt golf cart batteries. These are designed for a full charge and discharge cycle. Now, if I were to hook my motor directly up to the batteries, it would just spin like a propeller. Instead, I'm going to use a bridge rectifier. This acts as a sort of gateway for electricity, keeping it flowing only in one direction. In our case, from the generator to the batteries. Let's go outside and test this out. We mounted our turbine on the back of a pickup truck and took it for a drive. When the wind hit those blades, they really started spinning. I checked the voltmeter, and when we got up to around 15 miles an hour, the generator produced over 20 volts, more than enough to charge our batteries. All right, my batteries are fully charged. It's time to put them to work. I've got this 12-volt blender. I'm going to hook this up and make myself a delicious fruit smoothie. Fire it up. And the best part is this is being made with free electricity. I'm John Park. I'll see you next time on the Maker Workshop.
Major funding for MAKE is provided by Geek Squad,